There's a reason you won't find this formula in field manuals, even the old ones that have long since been declassified. During World War II, a discovery spread through the ranks that scared commanders more than captured enemy weapons or sabotaged factories. It didn't rely on industrial chemicals, it didn't require a lab, and it didn't need equipment beyond what a soldier could find in a barracks washroom. Troops realized they could take a bar of everyday soap, mix it with a common oxidizer used for laundry and sanitation supplies, and create an explosive compound so sensitive, so effective, and so dangerously easy to make that the military cracked down on any mention of it. It was quietly deleted from training material after a series of accidents, restricted to demolition specialists, and eventually banned from all public documentation. But the story didn't disappear. It shows up in engineer testimonies, in scraps of wartime notes, and in interviews decades later. Today we're going to walk through what that substance was, why it frightened commanders, why it worked, and how understanding it sheds light on the overlooked chemistry of World War II. How a routine cleaning supply became the foundation for a battlefield explosive. To understand why soap ended up at the center of this controversy, you need to look at the kind of soap being used in the 1930s and early 1940s. It wasn't modern detergent, it was real, fatty acid-based soap, full of long-chain organic molecules. When you combine a fatty substance like that with a highly concentrated oxidizer, you can create a fuel oxidizer pair capable of detonation. During World War II, the oxidizer in question was potassium chlorate, which appeared everywhere, medical sanitation kits, water purification supplies, even some disinfectants. Soldiers handling both substances discovered that when mixed in the right ratio and packed tightly, the chlorate soap mixture formed a crude but extremely powerful explosive paste. The chemistry behind it is straightforward. Chlorates are notoriously unstable oxidizers. The fatty acids in traditional soap act as fuel. When the two combine, they create a compound similar to some of the early plastique formulations, except significantly more sensitive to friction, heat, and impact. That sensitivity is exactly why commanders panicked and stamped out any unofficial experimentation. Why the mixture became so dangerous so quickly. For demolition engineers, the mixture had one notable advantage. It produced a surprisingly strong blast for something made from such basic ingredients, but for regular infantrymen or guerrilla units, the risk far outweighed the usefulness. Chlorate-based explosives are infamous for their unpredictable detonation thresholds. A slight change in humidity, a grain of grit in the mixture, or a bump at the wrong moment could cause the entire mass to go off. Reports from the British, American, and even German forces tell the same story. Once soldiers realized how easy the mixture was to prepare, accidents skyrocketed. Nothing spread through barracks faster than a trick that seemed both clever and accessible. Officers discovered homemade charges hidden in footlockers and field packs. Some were intended for improvised sabotage, others were simply experiments. But the casualties mounted, and those injuries had nothing to do with enemy fire. Commanders concluded that knowledge of chlorate soap mixtures was more dangerous than useful. Demolition units already had access to proper explosives like TNT, Composition C, and Nobel formulations. The improvised chlorate mixture became, unofficially at first, then formally, prohibited knowledge. Manuals were rewritten. Supply chains reduced access to chlorates for non-medical units. In some countries, the practice became so taboo that even post-war books avoided mentioning it. Why did this knowledge disappear from the public record but survive in specialist memory? Well, if you look at wartime demolition manuals today, you'll notice there's a gap. Early editions briefly mention chlorate mixtures as emergency compounds, but then, within a year or two, those references just vanish. What happened is actually pretty simple. The military decided that spreading explosive knowledge too widely was a threat to its own troops. Making TNT required a whole factory, but making chlorate soap explosives only took curiosity and, honestly, about 5 minutes of privacy. Engineers kept the knowledge because they had to understand every potential threat, including ones created by their own side. After the war, a handful of chemists who'd served in engineer units wrote about the mixture in academic journals, but the details were, really sparse. Their goal wasn't to teach the method, but to explain why chlorate-based improvised explosives were unstable, and why professional-grade explosives replaced them. For historians, this gap in documentation is a reminder that not every wartime innovation was welcomed. Some were deliberately buried to prevent future misuse. So, how can historians and researchers responsibly study this topic today? The real value in discussing the chlorate soap explosive isn't about recreating it. That's exactly what wartime commanders were trying to prevent. The value is in understanding the mindset of soldiers under pressure, the chemistry they had at hand, and the risks that came up when basic supplies could suddenly be weaponized. If you look at wartime engineer testimonies, you'll notice this ongoing struggle between innovation and safety. The same creativity that led to brilliant field solutions could also, unfortunately, lead to catastrophic mistakes. Researchers who study World War II from a scientific or logistical perspective often analyze these banned mixtures to understand patterns of supply shortages, improvisation, and troop behavior. In controlled academic settings, chemists use simulations and historical records to figure out why chlorates were such common oxidizers early in the war, and why militaries switched to safer alternatives by the late 1940s. Understanding these forgotten explosives actually gives us a much clearer picture of World War II's hidden problem-solving culture. This story isn't just about a banned mixture, it's really about the intersection of chemistry, desperation, and ingenuity. World War II was packed with inventions that changed the world, but it was also full of dangerous shortcuts that commanders needed to suppress before they did more harm than good. The chlorate soap explosive stands out as one of the clearest examples. It shows just how quickly knowledge can spread among soldiers, and how rapidly leadership has to react when that knowledge threatens more than it helps. If you're interested in more deep dives like this into the hidden, suppressed, or overlooked details of wartime history, make sure you subscribe to Strange History and share this episode with folks who appreciate serious, source-driven historical analysis. The past is really full of stories like this. Stories that were almost erased but honestly, just too revealing to ignore.